Welcome dear students to this video series of Basics of Electrical and Electronics Engineering. This is a very important course in terms of first year FY BTECH Engineering. Myself Dr. Ashish Murajkar, Assistant Professor in Department of ENTC, MIT Academy of Engineering, Anandi Devachi, Pune. So let us begin with the basic concepts of this course, that is Electrical and Electronic Engineering. Now, very first, let us overview the fundamental concepts of electrical systems. Before moving to the basic concepts, let us know what is electrical engineering and what is electronic engineering. Regarding to electrical engineering, as we know that electrical engineering is a branch of engineering that deals with study, design, development, and applications of electrical systems, devices, and technologies. So, electrical engineering is the basic branch of engineering which deals with power devices, the various types of circuits, the design and developments of the circuits, the power grid applications, the single phase and the three phase systems, etc. So, after completion of this electrical engineering 4 years course, an electrical engineer will work on a wide range of electrical systems, including power generation, power transmission, power distribution. He or she can also work in the domain of electronics, control system, telecommunications, and computer systems. I hope by this time the concepts of electrical engineering is clear to all the students. Now, after briefing electrical engineering, let us move on towards what is electronics engineering. As this is again a core branch of engineering and nowadays liked by many youngsters. So, what is electronics engineering? So, electronics engineering is a branch of engineering that deals with study, design, development, and applications of electronic devices, electronic circuits, and systems. As we know that nowadays the design of chips, the design of processors, the design of controllers, the design of motherboards. As we know that the government of India is also promoting the Make in India concept, in which the electronic engineers plays a vital role. The electronic engineers also work on wide range of electronic systems, including analog and digital circuits, microprocessors, embedded systems, VLSI design, control systems, and communication systems. So, dear students, let us move on to basics of or basic components of this electrical and electronics engineering. Now, any engineering or either electrical or electronic engineering is not complete without having the knowledge of the below 3 or 4 parameters. That is, what is voltage, what is current, what is resistance, what is the circuit, and what is difference between AC and DC. So let us start our discussion with what is voltage. My dear students, the another name for voltage is potential difference. And this potential difference, it is a measure of electrical potential energy per unit charge. So potential difference or voltage is also nothing but a force to carry the charges. It is measured in volts, that is capital P, and which is used to determine the force in which electric charges are pushed through a circuit. Right? So this is very simple definition of what is a voltage. Next, what is current? Now, as we know that the current is dependent on voltage. Voltage is not dependent on current. Until and unless you apply a potential difference to any of the circuit or to simple wire, the current will not flow. So what is the definition for current? The current is nothing but the rate of flow of charge or the flow of electrical charge through a conductor. Now, as we know that the unit of voltage is volt, the unit of this current is amperes. Again, the name of the scientist, ampere, capital A, and used to determine the rate of flow of electric charge in a circuit. Next definition. What is resistance? Now, we know what is voltage, we know what is current. Now, what is resistance? Resistance is nothing, the opposition for something. As we know that on the roads, there are speed breakers. Why there are speed breakers? To oppose the excess amount of speed. In the similar fashion, this resistance or a resistor, it opposes the larger amount of current in a circuit or through a conductor. Now, its unit is measured in ohms and it is used to determine how much a material resists the flow of electric current. My dear student, this is my third definition. Definition number 4. What is a circuit? A circuit is a closed loop through which electric charge can flow. As we know that there are two types of circuits. One is open circuit and another one is closed circuit. So inside a closed loop, the electric charge can flow. And how the charges can flow? It is not possible until and unless we have a battery. So a circuit consists of a source of electrical energy, that is a battery, wires or conductors, and electrical components such as resistors, capacitors, and switches that we are going to discuss in the coming slides. So this is my third definition. Definition number 4, that is AC and DC. So what is AC, what is DC? This is very, very important term in terms of electrical and electronics engineering, my dear students. Please make a note. So AC stands for alternating current, which is a type of electrical current that changes its direction periodically. We will discuss what is this cycle later on. And DC stands for direct current, which is a type of electrical current that flows only in one direction. To be quite specific, let us have an example of AC. So AC quantity example is your alternating current or single phase or three phase. While the example of DC is nothing but the source that you are generating through the batteries. Next definition, my dear students, related to Ohm's law. So Ohm, again name of scientist. This is a law which you might have studied in your science level, 8, 9, 10 standard or +2 level, especially in physics. So what is this law? So it states that the current flowing through the conductor is directly proportional to the voltage across it, provided the temperature and other physical conditions remain constant. So how can I express it mathematically? V equal to IR, that is voltage equal to current into resistance, or current equal to voltage by resistance, which is clearly explained in this triangle. The three mathematical terms of this Ohm's law: I equal to V by R, V equal to IR, and R equal to V by R. So after seeing the basic definitions related to electrical and electronic engineering, let us move on to some of the components. Now, what are the various components that are used for design of the circuits? It is listed in this particular slide. So we are having certain connecting wires. So we are having this wire joint. So please remember the symbol, dear students. So this is a symbol of cell, where the largest line indicates positive charge and the smallest line indicates negative charge. This is a battery, where set of cells are connected in series. This is ammeter used to measure the current. This is voltmeter used to measure the voltage. This is a galvanometer, which you might have been studied in your physics level. This is my electrical bulb. This is my resistance. These are the types of switches. This switch is called as open switch, and while this is called as closed switch. Or these are the examples of open switches, and this is the example of a closed switch. So my dear students, please keep in mind the electrical symbols of various parameters. Now, after seeing what are the actual electronic components that you are going to use while designing of a circuit, you can design the circuit by using the breadboard, by using the PCBs, by using various softwares. You can do simulations. So the various components used are battery, LED, that is light emitting diode, a capacitor, a bulb, a buzzer, a motor. This motor can be an AC motor or a DC motor, a switch. There are various types of switches which we are going to discuss in coming videos. We are having resistor, its color coding also we'll discuss in coming videos. Also, this is nothing but a diode. Diode is having two terminals. Di means two. The two terminals of diode are anode as well as cathode. Yes, dear students, so these are some basic electronic components. Now, lastly, let us discuss what is a potential difference. So, as we discussed, that is voltage. Voltage is also called as potential difference. So, potential difference, also known as voltage, it is the measure of electrical potential energy per unit charge, which is measured in volts. So, it is a force that drives the flow of electrical charges through a circuit. Now, let us take a small example. For example, if a battery has a potential difference of 9 volt, it means that there is a difference in electrical potential of 9 volt between the positive terminal and the negative terminal. So what is the potential difference between the two terminals, my dear students? That is 9 volt, right? So when a circuit is connected to the battery of 9 volt, the potential difference between the two terminals drives the flow of electrical charges through the circuit. So dear students, now only the concept of voltage is understood, but how much quantity of current will flow through the circuit, that we'll see in upcoming videos. I hope the basics of electrical engineering, electronic engineering, various definitions, various components, various circuit symbols are clear to you by this time. In the coming video series, let us focus more on solving the real-time examples of this electrical and electronic engineering. So thank you, dear students, for your patience listening. Thank you.